Hi, everyone. So in the chessboard example, we were talking about a function that looked like that. F of x equals b to the x, where b was 2. We were really talking about 2 to the x, the amount of money on square x of the chessboard. But that's just one of many exponential functions. 3 to the x, 4 to the x. These also represent exponential functions. 2, 3, and 4 are nice bases. Now, that's not an official term. We call B a nice base, or I call B a nice base, if B is positive and not 1. Then it is a legitimate base for a legitimately exponential function. F of x equals b to the x, where b is nice. We'll discuss these problem situations later on. All right, so let's take a look at the graph of this. How do we graph y equals to the x, our payment function from part A? All right, well, let's go to Desmos. Okay, so we can ask Desmos, what does y equals 2 to the x look like? And it's that J curve. All right, 2 to the 0 is 1. Okay, 2 to the first is 2, 2 to the second is 4, and so forth. I'll plot those points. 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4. Okay, remember, y equals 2 to the x, all right? And these are points on the J curve. Now, you can use the wrench here to change the scales on these axes. Right now, the scaling is equal on the two axes. Visually, you can make this look very different if you use different scales. Like, for example, what if we went from negative 100 to positive 100 on the y-axis? All right, then it would look a fair bit different. Okay, so the scaling does matter. All right, actually, let's go back to the original. Let's go back to equal scaling. Okay, so let's say negative 10 and 10. Let's go back to equal scaling. All right, well, here we have y equals 2 to the x. All right, here's y equals, well, here's y equals 3 to the x. Whoops, 3 to the x. Y equals 4 to the x. These are all J curves. All right, in fact, y equals 1.1 to the x. That's also a J curve. It grows more slowly than the other guys, but it is ultimately a J curve. It really is a J curve in the long run. All right. So as long as the base is more than 1, you're going to get this J-curve behavior. All right. Now, if the base is 1, that ain't exponential. That green line, that's not exponential. 1 is not a nice base. But if the base is a constant, a number greater than 1, then you're going to get a J-curve. Even 1.1. Y equals 1.1 to the x. That still gets us a J-curve, especially in the long run. Okay. Now let's talk more about this J curve. So I'm going to clean this up a bit. Okay, and let's zoom back in. All right. So let's say that we have y equals 2 to the x. All right. Well, we know that 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4. All right. But what about to the left of the y-axis? All right. What is 2 to the negative 1? Right? What is 2 to the negative 1? 2 to the negative 1 is 1/2 or 0.5. Remember that? 2 to the negative 1 is 1/2 or 0.5. So when we plug in negative 1, we get 0.5 or 1/2. And we get this blue point over here. What about 2 to the negative 2? 2 to the negative 2 is 1 over 2 squared. It's 1/4. All right. If you don't believe me, here are my notes, right? Okay, you plug in x equals negative 1. 2 to the negative 1, you're replacing x with these numbers. 2 to the negative 1 is 1/2. 2 to the negative 2, remember, you're plugging into the exponent, not the base. 2 to the negative 2 is 1 over 2 squared, or 1/4. If you plug in negative 3, 2 to the negative 3 is 1 over 2 to the third, or 1/8. All right, so let's plot those points. If you plug in negative 2, you get 1/4. And if you plug in -3, you get 1/8. So we're doing point plotting here. Okay, so notice all these points lie on the graph. We have the appropriate function values over here. So notice that as the x-coordinate gets more and more negative, the y-coordinates, the function values, appear to get closer and closer to 0. And by the way, yes, that is an HA. It's a line, a horizontal line, that this graph approaches. But the HA is only relevant to the left, not to the right. Exponential functions are not rational. Remember, rational graphs, if they have an HA in one direction, you have to have the same HA in the other direction. This exponential function is not rational. It does not abide by those rules. It can have an HA in one direction, but it's an HA that's not relevant in the other direction. In fact, this function, this graph, explodes out here. Okay, so notice that as x approaches -infinity, it appears that 2 to the x is approaching 0. Remember, we define asymptotes using ideas of limits and infinity. Okay, so the graph basically looks like that. In general, if b is greater than 1, then yeah, you're going to get a J-curve. So you're going to have many of the same features of this. So think for a moment. What are some features that are going to be common to all of these graphs? All right, so I'm just going to go back here. All right, take a look at this. Y equals 2 to the x, y equals 3 to the x, even y equals 1.1 to the x. What are some things they have in common? Think in terms of intercepts, domain, range. Intercepts, domain, range. And I'll see you in the next video.